Hey guys, want to build a robot? Hey guys, Matt here from ACVR. Now, I have been really excited to make this video. I mean, these days when we talk about wireless communication for our microcontroller projects, we are spoiled for choice, right? The ESP32 with Wi-Fi, BLE, the ability to use ESP Now. There are so many options, and there are so many other chips that utilize different protocols that are perfect in certain situations. But today, I wanted to talk to you about one of my favorite ways to very quickly, wirelessly get two Arduinos talking together. And now, if you have an ESP32, oh my gosh, check out ESP Now. I'm gonna have some tutorials for that down the road with some really fun stuff you can do. But say you have two Arduinos and you want to send some sensor data wirelessly without using Bluetooth or Wi-Fi, or you want to build a controller for a robot, you know, with some joysticks, maybe a gyroscope, and send that data to another Arduino controlling your robot. Man, that's when the NRF24L01 is perfect. We have the ability to send multiple data channels. There are all kinds of different NRF24L01s with different range. The code is pretty straightforward. And it's relatively stable. And so it's a chip that I come back to over and over again. I really love using it in my projects. And so today what I want to do is talk to you about the RF Nano that has the NRF24L01 built in, as well as your other options for using the NRF24L01 for all kinds of really fun robotics projects. So without further ado, let's get started. Now, one of the first things that I've got to talk about when it comes to the NRF24L01 is the sheer variety of modules that use that chip. So there are tons, and I have just a couple of them here. And in a lot of ways, the biggest difference in these different modules is the range. You know, some are a little bit more expensive, some have a little bit longer range. I'm going to get into all that a little bit later. But I want to make a couple of things perfectly clear before we get started. So whenever I talk about the NRF24L01, what I'm referring to is the IC itself. So this IC is made by Nordic Semiconductor, and they are an awesome company. So the NRF24L01 has been around for a few years now, but what's cool is there are still Nordic chips going into some state-of-the-art boards right now. In fact, the BBC Microbit, which got really popular for MicroPython stuff, used the NRF24L01. Even Adafruit's brand new Clue board used the NRF52840. So this company is still making awesome chips, and they're really good at what they do. So even though the NRF24L01 is a little bit older than some of these newer chips, it's still really capable. And so the most popular by far is this module right here. This, if you just search generally for Arduino NRF24L01, you'll see something like this. And these little modules are not bad. If you have two of these paired, your range could be close to like 100 feet or so, which is not bad, you know. Often in a classroom setting, when I'm using NRF24L01 for my robots, we really only need like 20 or 30 feet range. Now, radio obviously can go, you know, hundreds and thousands of feet, right? But these little modules are still pretty good. There are also service mount versions, right? So there's a service mount version of essentially the same thing. And so when it comes to the NRF24L01, these modules here simply have that one NRF chip. But you see, there are also longer range models. And this actually has a separate amplification IC. So whenever you're looking at these things, if you see one of these modules that has two chips, that is that secondary amplification module. But these modules get really crazy. So like I picked this one up on AliExpress a couple of months ago and did some tests, and it claimed to have thousands of feet of range. And so I don't know if that's exactly the case. I didn't see much of a difference between this long range module and this long range module myself. If any of you out there have used this module and got really good results with it, let me know, because I'm always searching for new chips. So there are the tiny little service mount ones. There are the standard. There are our long-range modules, and I wanted to bring this chip out too because this is actually my favorite. This is the Spark Fun NRF24L01 breakout. Now, this little chip, there are a couple things that are so awesome. So it has an onboard voltage regulator with a filtering capacitor built in. So you can use 5 volts and not have to worry about, not have to worry about having an extra board to work on that voltage regulation, which we'll talk about later. But what's also so sick is this module uses a ceramic antenna, and its range is really, really, really good. Now, it is also the most expensive by far. You can get these little modules for just a few cents. I think probably under $1. But if you pay $2 or $3 per module, you're not really getting like ripped off or anything. Same for these. These are about $2 or $3. I think I paid close to like $10 for this one. I'm not exactly sure. And this, I don't know the exact price right now, but I think it may even be in the $20 range. That being said, it is a really good chip. Even just having a straight pinout for breadboarding is super, super useful. So if you have the money, I say go for it. They're great chips, but also you don't need to spend a lot to get these things working. Now, whenever you see circuits using the NRF24L01, you'll often see a separate board for voltage regulation with some filtering capacitors on there. And now these are the most common driver boards. It makes the pinout straight, right? So there's straight rows of pins, and then also has, like I said, that voltage regulator on there, and you have your power in pins right here. Now, I don't want to make anybody mad, but I actually don't really like using these driver boards. That being said, you do have to have some kind of voltage regulation with filtering capacitors, right? You'll often see people solder a capacitor on the power pins, and that will get the job done because you do need that capacitor. But there are other ways to do it, and so this may be a little controversial, but I really love using this voltage regulator whenever I'm using an external NRF24L01. See, it has the voltage regulator on there, and it has some filtering capacitors and some other things that are super useful. So this is just a simple 3.3 volt voltage regulator, but when you wire this in line to the VCC or the power in pin on the NRF24L01, I've had really, really good success with it. It does the job. You have a good, consistent signal. You don't have to worry about the voltage frying out the chip, because if you do give this thing 5 volts, it will fry. And so you're not going to know if there's something wrong with your code, if there's some interference, or if your module's fried. And so it can be really frustrating. Sometimes you can get it to work just by plugging it in straight for a little bit, but the results are just not as good. And so I do recommend having a voltage regulator and a filtering capacitor. But using this module, personally, in my own classroom, like we said, we use NRF24L01 for our robots all the time. I love using this little module. It's really, really cheap. If you design a circuit board that uses it, it's really easy to embed into that circuit board. And you're not forced to use a module like this. I think if these were actually breadboard friendly, then maybe I'd be a bigger fan. But this just seems like an easier solution for me. But nowadays, believe it or not, I'm actually a huge, huge fan of this RF Nano right here. So this is a standard Arduino Nano, and it has the micro USB, but it has the NRF24L01 built into the board. This means that it is so easy to get these two modules talking to each other. You don't have to worry about that voltage regulation. You don't have to worry about any extra capacitors. You don't have to worry about any extra modules or wiring at all. This is just built in. Now, if there was a downside, though, to using these modules, it would be range. Like I said, it's very easy to get a couple hundred feet out of some of these modules, and that's really fun. It's fun to make super fast, long range robots. But I would say that within the confines of a house or a classroom or something like that, using these, one as a controller, one as a receiver for, say, a robot, is perfectly acceptable. You'll see a range of still about 20 to 30 feet, depending on certain factors. So it's not like the range is, 5 feet. Otherwise, I wouldn't recommend them at all. But I love these little guys. That being said, it is perfectly valid that the range is not as far as when you use these modules. So sometimes what I like to do is I like to put this module on a controller and then have a longer range radio on the robot. Because these modules are the same. You can interchange any of these. These are all the same chip using all the same protocol. And so it doesn't matter. You can absolutely mix and match. So just because you used one nano doesn't mean you have to use the other. You can also have a super long range NRF on the controller and stick this guy on the robot. What's nice about sticking this on the robot is that if it's bouncing around, it's not going to come loose. So like this module, even though it's a very good one, it's really heavy right over here. And so if you don't want to take the risk of soldering it in, if your robot is bouncing around, this can come disconnected as you're driving. And so it's really important to talk about the right kind of radio for the right job. Now, I want to mention again, too, I am a huge fan of ESP-NOW, the radio-based communication, the 2.4 gigahertz communication based with the ESP32. And I'm going to have a bunch of tutorials about that coming out really soon. And so some of you guys might be wondering, well, why don't you just use an ESP32? Which I love using those. But this is just if you have an Arduino robot, you're comfortable with Arduino, and you want to have a really easy way to make it wireless, the NRF24L01 is still an awesome choice, especially when they come built in like this, which makes it super, super easy. So the NRF24L01 uses SPI communication. And so because of that, 3 pins on the chip have to be plugged into the exact same 3 pins on any Arduino, and those are the SPI pins on the Arduino. So in the case of the Arduino Nano, we have SCK in pin 13, we have MO and MI, MI being D12 and MO being D11. Now, the only other pins that we have to worry about on the Arduino, on the NRF are the CE pins and the CSN pins. And so if you have an NRF24L01 like this, you can plug the CE and CSN pins into any digital pins you want. Now, I had to learn this myself, but if you have any issues with this guy, it's probably because those CSN and CE pins. So on the RF Nano, the CE pin is hardwired into pin 10, and the CSN pin is hardwired into pin 9. And so if you use this RF Nano and you find some other NRF code somewhere else, it's probably 100% compatible. You just have to make sure that you still declare the CE and CSN pins, and you have to make sure that you assign CE to 10 and CSN to 9, even though there aren't any physical wires connecting the module to the board because it's all embedded like this. And so on the blog post, I'm going to go into way more detail about how you could use this with a regular NRF or an RF Nano. But for the purposes of this video, and not wiring everything twice, I'm going to use all of my examples here using the RF Nano. So I'm going to have one RF Nano sending some data and the other receiving. It is absolutely possible to get two-way communication going, right? So sending and receiving, receiving and sending. I'm not going to get into that in this video. This is going to be more for just, say you have a controller and a robot, but just know that it is totally possible. I'll probably have a tutorial about that too coming out before too long, but I want to make sure we have this out there just in case any of you guys are trying to use this. So we do, like I actually ship all of the Arduino robots with this RF Nano, whether it needs it or not. So the ACBR rover uses RF Nano. Even our older robotic laser cannon kit, which is really fun, uses that same RF Nano. And so the reason I included that is because if you ever wanted to make it wireless, you have that option. I also have our universal wireless controller that uses this same NRF Nano, and so it makes it really, really, really easy. And so I wanted to create this video for those of you guys who may have those products and are looking for a little more of an in-depth guide about how to get the whole thing working. So let's go ahead and let's add some components here, and so that way we can see if this thing is going to be able to do what it is that we want to. So we're going to start off using the MPU 6050 gyro. Again, one of my favorite gyroscope chips. You know, as the accelerometer data that you get from that is reliable, and those modules are really, really affordable, it's going to be a great way to start sending some really, really fun data in between these two modules. So let's go ahead and grab our MPU 6050. We'll wire it up to a sender, and then we'll set up our receiver sketch. Now, integrating the MPU 6050 accelerometer data into your project is really, really, really easy. As you can see, we only need 4 wires to get the data from our pitch and roll over to the RF Nano and then send that data out using the NRF24L01 radio. And so that means that the kinds of projects you can create with this are insane. You know, I had some students put an MPU 6050 in a hat, and they had the RF Nano transmitting that data wirelessly to a robot. So all you had to do was move your head around, and then the robot would react. You know, there's some people who like to put these in a glove. There was one time we put the MPU 6050 in a lightsaber and controlled a remote control R2D2. But so you move the lightsaber around, and then the R2D2 robot reacted. And so it's a really fun chip. And the MPU 6050 itself is really affordable, really consistent, and also really, really easy to integrate. And so I really love using these in my projects. And so sending that accelerometer data wirelessly, thanks to the RF Nano, is really, really, really easy. Okay, so if we take a closer look at the MPU 6050, there's just 4 pins that we need to worry about for right now. The first one being VCC, and that's going to go to 5 volts. You're going to want to give this thing a full 5 volts, not 3.3. Next, we have the ground pin. So the ground can be connected to any ground on the Arduino, doesn't matter. And the pins that I really want you to take notice of are SCL and SDA. So whenever you see SDA and SCL, the first thing that should pop in your head is I2C, because this is an I2C chip. Now, if you've started working with Arduino, you may have noticed that there are tons and tons and tons and tons of modules that use these SDA and SCL pins connected to your Arduino. And that's because it is a really, really useful communication protocol. Now I know like SparkFun uses them all the time in their quick connectors. I think even Adafruit uses them for their stemma connectors, some of the newer ones. So it's really, really useful. And so what's so cool is even though we have a lot of really powerful accelerometer data, getting that data to the Arduino is really, really, really easy. And so whenever you see those SDA and SCL pins, you should think A4 and A5. So on a standard Arduino, as well as the Arduino Nano, the SDA and SCL pins are hardwired into pins A4 and A5. Now, there are some newer chips like the ESP32 that can program their I2C bus, which is really useful. But in this case, because we know that we're dealing with an Arduino, we know the wiring is super, super easy. And so our VCC is going to go to 5 volts, ground is going to go to ground, SDA is going to go to A4, and SCL is going to go to A5. And so that wiring is super, super easy. So we see here that I have my VCC pin, sure enough, going to 5 volts. I've got ground going to this ground right here. I have SDA and SCL, SDA going to A4 and SCL going to A5. Now, I know this is way easier to see on a wiring diagram. And so if you want an actual physical wiring diagram rather than just the picture of the wires, head over to the blog, because I'm going to have lots of schematics that'll make this a little bit easier to see in terms of how this wiring is, if it's hard to see from this perspective of just those wires. But in terms of the wiring itself, we're done here. And so what I want to do now is head over to Arduino. I'm going to show you the sketch that we need to take this data and send it out. And then we're going to send that data over to another RF Nano. Once we have that communication working, then we'll see what we can add to the receiver Nano to make some pretty cool projects. And so with that, let's head over to Arduino. All right, so now that we have the MPU 6050 plugged in and wired up to our RF Nano, we've got to write some code to send that data out. And so that's the goal of the example code you see right here. Now, I think on the tutorial, I'm going to post some more example code, maybe just sending over an integer or something a little more simple, because I want to make sure that this NRF24L01 code is as clear as possible. You know, I'd love for you to go through this tutorial and think and know that you could adapt it to send whatever you want. So I may put a more simple example on the tutorial post on our blog, but for right now, our goal is to take the data from the MPU 6050 and send it back out. So here in the comments above, I've included the pins for if you wanted to use an external NRF24L01. Obviously, if we're using our RF Nano, that wiring is done for us. But just in case, I wanted it to be really clear that this code is fully compatible with using any kind of NRF24L01. That is so long as you still plug your CE and CSN pins into 9 and 10. The wiring for our MPU 6050, right? Super easy, just using SDA and A4 and SCL and A5. And then we come to the code itself. So there are quite a few library files that we need here. As we discussed before, the NRF24L01 uses SPI communication, and so we need the SPI library, obviously. But also, we need the library file for the actual NRF24L01. So this is really important, and something that I had to experiment with for a long time. So back a few years ago, there were two libraries that were made for the NRF24L01, and unfortunately they used the exact same file names, so RF24.H. And I've found that one of those libraries I enjoy using way more. So there's one library that was created by GitHub user Maniac Bug, and that's the library that I use. You know, I'm sure there are other situations in which that other library is really useful. But just from my own experience, if you run into any issues and you've already downloaded the NRF24L01 library in the past, I would use the library that I have linked in the description and on the tutorial. Not that there's anything wrong with the other library, it's just that I've found that the Maniac Bug version of that library is way more consistent and really useful. There are also some other compatible libraries out there. I think there's like an NRF Lite library I've used before, also the Radiohead library, and those are great. I really love using the Maniac Bug version of this library. I think it's awesome. Okay, but enough about libraries. So because the MPU 6050 is an I2C device, we have our I2C address. Of course, we need to have wire.h in order to start the I2C bus. If you remember before, we have CE and CSN of the NRF24L01. In the case of the RF Nano, hardwired in. But if you're using an external Nano, then you want to make sure that you have those pins wired in that specific order. Okay, so the NRF24L01, one thing that's really cool is you can use a communication pipeline, so you're not limited to having only two ever, you know, without interference. Say you wanted two robots driving side by side that both had their own controllers. You could give them individual pipelines. Now, in some examples, you'll see a really long hexadecimal address, and you can use a really long, complicated hexadecimal address if you want. I just use the number 1 to keep this really easy. So if you don't want interference and you have another radio-based project, you're going to want to change up your pipeline. Okay, so this data right here, this is just for our MPU 6050 to get our accelerometer data and then calculate what we'll call pitch and roll. So roll being kind of side to side, pitch being leaning forward and backward. Now, because we have 2 bits of data, we have a pitch, we have roll. In order for the receiving NRF24L01 to be able to interpret that data and separate the two, we have to have a way to combine it all together, and we do that using what's called an array. So here I have established an array with 2 elements. Now, if you've done like Python programming or even some Java or other C++ stuff, and you may have encountered arrays before. They are very useful and very common. For lack of a better term, because this isn't a whole tutorial just about arrays, it's like a list. You know, I have my gyro list, and it has 2 things in that list. And so, in reality, lists and arrays are 2 different things in certain languages. But don't worry about that right now. All we need to know is that I can combine pitch and roll together by creating an array that has 2 elements in it. And we're going to populate those elements down before there. Okay, so in the void setup, obviously we want to start up our serial monitor. This is just for debugging. You know, we want to make sure that the data that we're seeing on the sender side is the same as the data we're seeing on the receiver side. Because if we opened up our receiver and saw nothing on the serial monitor, then we wouldn't know if it was the communication or if it was the sensor or any of the problems. And so it's useful to have that serial print statement, even though it's not necessary for the actual transmission of that data. Okay, so we're starting up the radio. This is the initialization line for the MPU 6050 that just gets the I2C communication running. Okay, now in the void loop, this is really cool. So in reality, the entire void loop is pretty short. You know, we're dealing with some crazy stuff. So we're calculating all kinds of crazy stuff, and we're sending out that, for lack of a better term, gesture data or accelerometer data out wirelessly, which is really cool. And so the .write command is how we send over our array. So now this line right here, so send out gyro, size of gyro. What's cool is we're not limited to a 2-element array. You know, I've seen all kinds of really cool stuff where people put they'll put an NRF24L01 inside of an old Super Nintendo controller and send out all of the button data that way. Or, you know, you could send the joystick data as well as some gyroscope data. You are not unlimited in your amount of channels. You know, there's a certain amount of memory you can handle. That being said, if you want to send a few analog channels, a few digital channels, you know, send over some integer data. It is not difficult. And we'll see, if you look at the example code we have for our universal radio controller, we do exactly that. And so keep in mind you are not limited. So this is basically saying send out your array, however large your array is. Okay, so the MPU functions. This is actually in a method that's down below. So we do have some methods that are running in the background, but don't worry about that don't worry about that too much for right now. So in this case, we have our pitch and roll, and that's the thing that we're trying to send out. And so the pitch and roll are calculations based on the accelerometer data. So you see we have the X, Y, and Z right there. So the accelerometer data is what gives us our pitch and roll. And so this function's pitch and roll is also another subset of the methods that are doing some more intense calculations for us, which is really nice. That makes this really, really easy. Okay, so if you remember, I created a 2-element array. 2 elements. And so I basically have 2 slots in this thing that I'm trying to send out through the air. And so it's really important to remember that computers always, always, always start counting at 0. Humans, we almost always start counting at 1, right? But computers, they start counting at 0, and that's really, really important. So in this case, the very first slot in my element is actually at position 0, and the second slot is at position 1. So even though I have a 2-element array, to populate my array, I've got to put pitch into position 0, and I've got roll into position 1, which is actually my first and second position. I know that's kind of confusing if you're first starting out. Just keep in mind, computers start talking at 0. And so if you want something to be in the first position, you've actually got to name it the 0th position, which is really weird. Okay, so in the rest of our void loop, all I'm doing is printing that data back out. So I have the pitch and roll data coming back. And like I said before, that's just so that we can tell that the sender is working as well as the receiver. And that's just for debugging. Okay, so if you're curious, you can take a look at the other calculations that are happening in the background. So we have the functions MPU, functions pitch and roll, and the initialize method. And it's pretty cool, you know. So the initialize method, like I said before, just talks to the MPU 6050 to make sure the I2C communication is good to go. But you should not need to mess with that at all, because those are just functions for that MPU 6050. In terms of the actual radio, sending the data is really, really, really easy. And so we will leave it at that. Now that we have this working here, you know what? Let's go ahead and open up the serial monitor. So I'm going to open up the serial monitor so that we can see if the pitch and roll is actually working for us. I was working on some ESP32 stuff, so I've got to reset my tools tab. Actually, by the way, in case you're ever figuring out how to program the RF Nano like you are now, it just shows up as a regular Arduino Nano. It's got the new bootloader, not the old bootloader, in case you were wondering. All right, so we open up that serial monitor. Keep in mind the baud rate here is 9600, so it's pretty standard. Most times when you're dealing with straight up Arduino stuff, that's what you've got. And so if you have the MPU 6050 relatively flat, you should see pretty close to 0 and 1. This library converts pitch and roll into varying amounts of 0 to 90 degrees, both in the side to side and the forward and backward. So we have 0 to 90 degrees forward, 0 to negative 90 degrees backwards. And the same for left and right, which is really, really useful. So if you move this thing around, you'll start to see that data, which is really useful. So even though our goal is to send it out via radio, it's always a good idea to see if it's working on the sender side. Okay, so without taking any more time here, let's go ahead and let's open up the receiver circuit and get that guy working. Okay, so now that we know the MPU 6050 data is going into our sender RF Nano, we're sending that data out, it's time to look at the code that we need to receive that data. So one thing that's really cool about the NRF24L01 is that the sender and receiver code look really, really similar. There are a few key differences, and I want to make sure to talk about that here. But in terms of complexity, it's you don't need too much more. You're basically just setting up the receiving channel to unpack the array that you sent across. So let's take a look here. Obviously, we still need the SPI library. We still have those NRF24L01 based libraries. But if you notice here, I included the servo library. Rather than just see the pitch and roll data on the serial monitor, I thought it'd be fun to put that data to work a little bit. So I'm plugging the receiver RF Nano into one of our robotic laser cannon kits because using servos is a really great way to visualize that pitch and roll data. And so, like I said before, I think I'm going to have a more simple example of just sending over maybe one set of integers, or something like that. But in this, it may look a little more complicated because I'm adding in some servo control code. But if you want more detail, like I said before, just head over to the tutorial because I'll have a little bit more detail there. Okay, so the pipeline. This is really important. You've got to make sure this is the same. If you're running into any issues, I would definitely check to make sure you have the same communication pipeline. In this case, we're using the number 1, keeping it real simple. Okay, the array. So since we're sending an array with 2 elements over, we have to receive an array with 2 elements. That's really, really, really important. Because later in the code, we're going to unpack that. And if those things don't match, then we're going to have an issue there. Okay, so these variables here, laser, position X, servo X and Y, all this stuff. This is for the robotic laser cannon. And I don't want to go into too much detail about that on this video. I think I might do a whole build design tutorial thing for it later. But we'll see. Just keep in mind, these variables just have to do with the robotic laser cannon and the servo movement. Okay, so in terms of the radio here, we're starting up our serial monitor, right? Obviously, we want to see if that data is coming across. Okay, so in this case, we had a writing pipe before, and now we are opening up a reading pipe. And so there's this command here, start listening. That's really, really, really important. Okay, now in the void loop, this is where we actually get our radio data back. In this case, I just turned on the laser, right? But this is really important, this first conditional statement. So we have a few nested statements here. The first is that if radio is available. So if radio is available while you're receiving data, I want you to read the array, however large the array is. And then print out the first position, print out the second position. Now, this is all we need to actually get that radio data, this little chunk right here. So it's relatively simple here. Now, this part of the code, this is using the gyroscope data to increase and decrease a position variable to move some servos around. So this is just using gyro position 0, using the data from gyro position 1 right over here. But it's really important. So it's really important that with this this first conditional statement, right? So if radio is available, get the data. If not, print out that it's not working. I personally think it's really important to have that statement there because if you just have a blank serial monitor, then you don't know what's going on. But if you're able to print that error message, then you know the issue is the communication. And that makes it easier to debug. So say you're using external Nano and you get that error message, you know the problem's communication, you can try swapping out a different radio or you can try using some different hardware. So that's really, really important. But in terms of just getting my data, it's pretty easy. Okay, so the first thing I would do to check if this thing is working is open up the serial monitor. So let's go ahead and do that here. So we're going to open up our serial monitor. And we should see our gyro data. Technically, accelerometer data, but you know. our pitch and roll, we'll call it that, the pitch and roll. So if you remember, I said before that if you have the MPU 6050 relatively flat, then you'll get pretty close to 0, 0, going 90 degrees in either direction. Okay, so it looks like we are good to go. We are receiving that gyro data. So now what we're going to do is we're going to go ahead and plug our sender and receiver RF Nanos into some circuit boards and have some fun. All right, now that we have our wireless communication all set, it is time to put that data to work. So all I did here was I took the receiving RF Nano and plugged it into one of our robotic laser cannon kits. I don't want to go into too much detail about this guy right now. Just know that I have 2 servos hardwired into the RF Nano, which make it really easy to see that gyroscope data. Rather than go into this whole thing right now, I think I'm going to do a whole build design tutorial for that project later. But that is our receiver circuits. We have the same RF Nano getting that MPU 6050 data. And so the sender circuit, rather than use the breadboard we had in the previous example, all I did was I put that same sender RF Nano and the MPU 6050 into one of our universal robot controllers. And this is a really, really great way to just make it a little bit easier to get that wireless control started, you know? And so we have both of these up in the shop. If you want to pick one up, man, that'd be awesome. I will tell you that you know, one of our biggest goals in ACBR is to donate as much robotics equipment to students in need all around the world as we can, because that's my whole goal. You know, I wanted my classroom to extend around the whole world. You know, and that's why I started doing these videos. And also, if you want to go into more detail, keep in mind we have the tutorials on our website, and they have more circuit diagrams and more example code and stuff like that. And so the goal of this video is just to show you how easy it is to use the RF Nanos to get 2 Arduinos talking together and all of the really fun projects you can use with this stuff. So with that, that's all we have for you guys today. Thank you guys so much for watching. Feel free to check us out on Instagram. We also have our website, and if you like this, let us know, and keep hacking, guys.